All right, so I'm gonna actually just take the time because that's gonna save us a little bit of time that morning. But all the units are sectioned off. You've probably noticed that already. There's a little bit of overlap sometimes where they, like for example, if you do probability, it might be that one of the questions bleeds into finance, like they combine it. But it's not like you're not going to be able to do it if you see it. It's going to be the same as before. And logical reasoning is always usually the last. And you've probably seen some of the games that they have at the end, games and numbers they call that. When we get to next week, I'll talk a bit more about those ones. And the directions, make sure you read carefully. Okay? Does it say probability? If it says probability, you have to have, right? You have to answer like this, where you come up with a number and then total at the bottom. So read carefully, please. Is it asking for payments or years, right? When it comes to TVM solver, like what is it actually asking? Okay. It is okay. You want to indicate your inputs when you're using a function. L1, L2. I'm using sine, reg, you name it. We're not going to have to worry about additional pages. It never happened that somebody needs more space than what they provide. 2 decimal places, your final answers. Okay? So here's an example. 15 over 29 is 0.52, but if you round it to 2 decimals and you turn it into a percentage, it's 51.72%, right? Because 15 over 29 is 0.5172. So you round it to that. Okay. Also, this is important for you. If it says graphic organizer or visual representation, you may use a tree diagram, a chart, a list, a Venn diagram, truth table, Pascal triangle. We didn't do Pascal. If you do pre-cal, you will be exposed to that. So I guess they still have it available if you want to use it. Next, you need to make sure that it's easy identified in the response space, right? Your answer. I would say always circle your final answer. Don't make us guess, because you could lose marks if we have to guess. So either have a clear label or have a circle around this is what was answering the question ultimately. Make sure, please don't forget your y equals when it's equation or sine, natural log x, anything like that. If you miss it, you lose half a mark. But the beauty is you only lose it once. Okay? You don't lose it consistently throughout the exam, but still it'd be nice not to lose. Always include your units where applicable. Label units and scales when you're graphing. Okay? So if it's an exact value, we need to round, obviously. Okay? So now let's get started. You may use your formula sheet. We will not tear this one out because it's from 2015. It has changed somewhat. Every exam has a formula sheet, so we're just going to leave that for now. Okay. Short and sweet. They tend to start with functions. So that's kind of how you're going to start the exam. Not always. They change up the order. Which of the following functions has an unrestricted domain and an unrestricted range? What that means is it means which one of these has this as the domain and has this as their range. Like both of them are not restricted at all. You could also talk about it in this way if you want. So that's where the wording is important. So which one of these would fit the criteria? Quadratic, it can go like this or it can go like this. So quadratic is not it. It's not, right? At some point, y is only good this way or that way. So quadratic is not it. Logarithmic, if you do a log, is it unrestricted when it comes to the domain? A log never crosses the y-axis, so it's also not the log. Right? Exponential, this is log, by the way. Exponential is the other way, where you have your asymptote here. So the domain is unrestricted, but the range isn't. So it's also not it. So in this case, it's the cubic function. Okay, because your cubic, regardless of how it goes indefinitely in the x's, indefinitely in the y's, right? So that's what one marker right there. So if you don't know what it is, maybe eliminate which ones aren't candidates, and then you just go with that, okay? All right, keep going. 1 mark. Another multiple choice. Which of the following is a logarithmic? I'm going to zoom out here. How do you know something is a log? There is no y-intercept. That's one thing that comes to mind for me. So this is a no-no, also a no-no. This is a linear, what are you talking, right? So D is the only candidate that fulfills that requirement of not having a y-intercept. They're not going to include the asymptote, right? That is just for us. We should know that the asymptote is there. Okay. So D is the right answer. Keep going. You good? And I'm recording this, so if I'm going a little too fast, you can always go back and check. 2 marks. Watch this. 2 marks. Right? There's going to be a bit more than meets the eye. Sam is studying the characteristics of quadratics. She states the following. Statement 1, statement 2, 3, and 4. 2 of these statements are incorrect. Okay, so they're telling you 2 of them are wrong. Identify them, so tell us which ones are incorrect, and provide a counterexample for each. Let's see here. Statement 1. A quadratic function always has a degree of 2. What do you think? That's true. The graph of a quadratic function always extends from quadrant 2 to 1. It's not always 2 to 1, right? The always is the problem. So this is wrong. We'll fix that in a bit. The graph of a quadratic always has one turning point. That is true. Right? It either turns there or it turns at the bottom, but it turns. So that means that this one has to be wrong. A quadratic function always has 2 x-intercepts. That is wrong as well. So we've identified it. I will just make sure here to say statement 2. Statement 2 incorrect as a quadratic can extend from quadrant 4 to quadrant 3. And I'll just give an example. All you have to do, in this case, it's not to scale. Okay, that's not the intent here. It's just seeing if you understand. So if you do one like this is quadrant 3 and this is quadrant 4. That's a counter example. And you can also say that A is negative, right? The leading coefficient is going to be negative. 1 mark. You got 1 mark if you got that. And remember, use your own words, use your own ways of expressing. That's fine. I'm reading this. Statement 4 is also incorrect. A parabola may have 0, 1, or 2 x-intercepts. Zero, 1, or 2. And we'll just give an example. You just have to give an example where it's not always 2. So you could do one of these and just have it not even touch the x-axis. Okay? 0 x-intercepts. That would be good enough. can also have 1, and that's when the vertex is sitting right on the x-axis. Okay. 2 marks. So far, it's just basic, right, understanding. Do you understand functions in general, right? No word problems yet. Not a single word problem. That's why we always hover around. All right, so there's a table. Question 4. The table below shows the electricity consumption in gigawatt hours. Can I just mention this? They come up with some weird units from time to time. But it should not scare you whatsoever. You just use the units they come up with. So in a large city since 1960, okay? So you've got the year since and then the consumption. Determine the equation of the what? Cubic regression that models the data. So let's do that. You should follow along because of the window. That's the problem. They're going to want to see, do you understand how to graph this on your screen and find things on your screen? That's what they're checking for. Okay. This one is like, did the teacher even teach you anything? Right? This first one, the regression. And be careful. So kind of have to find that middle ground where you don't go too slow, but you also don't want to mistype. Take that extra second to check if you're doing this right. And it should definitely match. If you get a domain error or something, you probably, something didn't go right. I will indicate up here that this is L1, this is L2, and not only that, this is my X value. These are my X values, the years, and the L2 are my Y values. Let's do the regression. Stat, calc, cubic regression, L1, L2, alpha trace. There you go. So I'm just going to do cubic reg. That's good enough. 0.44 x cubed minus 37.02 x squared plus 981.72x plus 12,631.56. That is your, if you're off, you're going to lose a mark, okay? That's it. There's nothing else we can do. So you got to make sure you're careful when typing this in. But you still get a chance in B. So I have to then type in what you got and figure out B for you, okay? All right. B, using your equation in A, estimate the electricity consumption in 2015. Show your work and round your answer to the nearest whole value. Sometimes they tell you that. Slow down. Slow down. So 2015, that means that, and it's a 2-mark question, right? There's some work there. So we're going to go 2015 minus 1960, because we have to figure out how many years past 1960 we are. So that would be 55 years. And for us, years is our X. They want to know what the consumption is at that point. So we're going second trace value, X is equal to 55. And the tricky part is going to be our window. So let's see here. I'm going to hit graph. Oh, I'm going to get rid of that. So I think I want you to actually try to find a window that works here. One thing that I'm going to look for is my points that I already have. This is my X, right? So I'm going to go window, And X max should be at least 50 or more. I'm going to set that to 100 maybe for now. And the consumption, look at how high these values are. So your Y max should go to probably 30,000, 40,000 or something like that. I'm going to go 40,000. Hit graph. And all of a sudden you start seeing more. So when you have a table, just go off of that. So now we're going to try second trace 1. X is equal to 55. And there's my Y value. That's 28,684,19. Okay. It says whole value, nearest whole value. So we're going to say 28,684, and we're going to throw in the units that they wanted me to throw in. All right, done. 3 marks. Zoom fit. What's that? Was that like that the whole time? My bad. So this second trace 55, we get that. Because they said whole value, only because of that, this is not very common anymore. They usually go by, like, they just want decimal unless it's like people or anything like that that you're finding, bacteria. Okay. So that is my consumption in 2015, which would be 55 years since 1960. So there was probably a mark associated with the 55, and then there was a mark associated with finding that. Question 5. We're doing okay? Yeah. Question 5. Total of 3 marks for question 5, right? So it's 1 and 2. George is diabetic, and the amount of sugar in his blood, which is the concentration, gradually decreases. That is probably worth noting over time according to the function, where C is the concentration and T represents the time in minutes. I can't tell you enough how important it is to know that this is our X value, right? Whatever is there. So in this case, time is our X value, and concentration is our Y value. Okay? Always, when you have the equation, that's how it goes. So getting that straight is going to be extremely important. His initial blood sugar concentration is 9. Can we tell that this is the case? Initial is 9. You see it right there that that's the case. So sometimes they're just giving you too much information perhaps, or they're trying to see, do you understand, or is that going to throw you off? State the range in this situation. What would be the range in this particular case? Let's have our little diagram. You could do that on your calculator if you wanted to. Sorry. For an exponential, it's here, right? This is my... So we're starting here, and what's happening to the function? Let's say this is 9. We're told it decreases. We also know, how else can we know that this is decreasing? This is, you can call it less than 1, but just, it's not going to be negative, right? Between 0 and 1. Yes. B is between 0 and 1, okay? It's dk, right? So technically, you just go ahead and it never touches the x-axis. It just never does. So what would be the range in this situation? Almost 0, right? Range is, we're talking these values, right? Range is always here. Almost 0. And can we include 9? Yes, 9 is included. So it's, right, 0 is right here. So it's between 0 and 9, but 0 is not included. Or, if you wanted to state the range using interval notation, you got to go squiggly brackets. Then you got to go 0 greater than You have to use the C letter. That is the Y, okay? And then less than or equal to 9. So 9 is included, 0 is not included. I would say stick with interval. Okay, just stick with interval notation. Don't go this. That's just my opinion there. Okay, George forgets to eat that his morning snack. He experiences dizziness once his blood sugar concentration drops below 3. After how many minutes will this happen? It says minutes, right? So it could be hours, seconds, whatever. They ask for minutes. So in this case, they're saying that if they want the time when the concentration is 3, okay? So we essentially have to write, to find this, we have to go y2 is equal to 3, and we're going to go second trace intersect. So let's go ahead and do that. I'm going to ask you to enter that first original equation that we were given. Enter that into your calculator. 0.995 to the power of x. Okay. I'm going to change my window right away. It's not, these huge numbers in the y max is not needed. I'm going to go up to 10 in my y max. That's as high as I'm going to go. And I'm going to hit graph. And there it is. It's dropping, right? And I'm going to let y2 be 3. And I clearly realize I need to increase my x max, right, to see a bit more. So we're going to go 250. I'm just guessing, right? There it is. It hits it right there. So find that intersection. And here you have it. X is equal to 219.17. And what are we in? We are in minutes, right? Because we were told at the very beginning that time was in minutes, so we can just leave it like that. No need to convert. All right, 10. All else fails, try zoom fit, right? If you can't even see the curve, try to make it fit. Here's your sinusoidal modeling question. The top of a flagpole moves back and forth on a windy day. It sways 15 centimeters to the left, which is negative 15, and 15 centimeters to the right, plus 15, from its resting position at 0. So right away, they gave you the min, the max, and the mid, by the way. It moves back and forth every 2 seconds. What is that? Moves back and forth every 2 seconds. That's the period. Yeah. At time 0, the pole was at its resting position before swaying to the left. Okay, so this is important. This tells you where to start. Starting point. Okay, exclamation mark. So they need to give you the, you need to be able to do the 3 lines here. 1, 2, and 3. We know that this is negative 15, this is 0, and this is positive 15. Where do we start? First of all, we're starting at time 0, that's worth noting. And we start, in this case, at the resting position. So this is one of the weird scenarios where you actually start in the middle. That's why I chose this one. You start here at time 0. And now they have to tell you, are you going up or down? What does it say? Resting position before swaying to the left. Left is negative 15. So that means that from here we're going to go to the left, back to the middle, to the top, and then back middle. So there are 3 midpoints in this case. And our period is 2 seconds. I don't know if the back and forth throws you off, but if you think about it, if this is the start, if you go back and fourth, right? That is a full cycle, so 2 seconds. So the x scale will be 2 divided by 4. This is 1/2, right? 0.5 of a second is going to be our x increase. So we go from 0 seconds to 0.5 to 1 to 1.5 to 2. So that's a full cycle. You've got 5 points. That's how you know you've got a full cycle. So let's determine our equation now. Time and distance. I'm not sure how else to do this. 0, 0, 0.5, negative 15, 1, 0. I'm just reading this off, right? 1.5, 15, and then 2, 0. This is L1, this is L2. Sin reg. Let's come up with our equation. And it's also good to just go through the motions, like where do I find this regression again, right? And there it is. 15 sine of 3.1416x minus 3.14. And this is what I wanted you to make note of. What's D in this case? You might be tempted to say 2.76, but every time you have one of those E negatives, that's 0. And we know that our midline is 0, right? So please don't be doing that here. If you do this, you're fine. But it's better to probably just leave it alone. And so note D is equal to 2.75, and that keeps going. E to the negative 13, okay, that's 0. Okay. Midline is 0. So all these little things just add up. You would have lost the mark most likely on that equation. So that's why you want to be extremely careful and go through these so you don't make those mistakes. This is, and this, I told you, usually they don't make you graph. This one they did make you graph. But this was in 2015, so it's been a while. So let's go to the next page where we graph. And so we're starting at time 0, so and I want 2 cycles, so I need to have 2 and another 2, so 4 seconds total. I'm going to go 1, 2, 3, 4. I'm going to call this time in seconds. I'm going to call this distance in centimeters. And I go 15 negative here. This is 0, and I'm going up to 15 here. It's probably a good idea to have those lines marked out. And in this case, the midline is right on the x-axis. So I start in the middle. This is 1, 2, 3, 4. So it's 0.5 to here, another 0.5, another 0.5, 0.5. So you just keep doing that. So if you start in the middle, and then if it doesn't tell you to stop, just arrowhead, right? We cannot go to the negative, so because time starts at 0, but here you can go indefinitely towards the positives. So in this case, it is actually fairly easy to put the points exactly where they're supposed to go. If you get some kind of weird decimal, close enough is good enough. Okay, that's a saying in the applied when we have training. Close enough is good enough. So we're not going to split hair over that. C. On an even windier day, the flagpole moves back and forth every second. Okay? Explain how your equation will change. And explain means, yeah, just use your own word. Justify, explain, anything like that. It will affect, so the equation, right? It will affect what? Which variable will it affect out of A, B, C, and D? Well, how do you get your period? It's 2 pi divided by B, right? It will affect B, okay? In y is equal to a sine bx plus c plus d. Just make sure they understand. It will affect B in that. In this case, it will, what do you think will happen to B? Will it get bigger or smaller? Let's do a bit of an experiment here, because you can do that easily. 2 pi. If I have 2 pi divided by 2, I get pi, correct? 3.14. If I have 2 pi divided by 4, I'm increasing B. What would I have in this case? Half a pi, right? So the period is smaller here, okay? So in this case, it will increase the value of B. And if pi is a problem, what's that? A higher value of B makes the period smaller. And the period is smaller because it's not every second from every 2 seconds. So it's faster. Okay? So I will just say here smaller period. Oh, you can't see that. Sorry. Smaller period. I will say this. The original does this. The new one we were just talking about is going to be more like this. Right? It's going to do this faster. It's going to do more ups and downs in a shorter time. Okay? So you're compressing. Even that, I would say, is part of your explanation. Right? Just throw it in there if you're not sure. That concludes functions. Unusual to have that many. They moved away from that. They moved away from, because guess what? Some students, not many, but they would even just give up right here. It's like, I'm done, I can't do it. So they couldn't do the graph and they couldn't do this one. So now you lose like potentially 6 marks, right? So that's why they're moving away from that. But I would say be prepared for anything. Let's go probability here. Select the best answer. I would like you to read that one and do that. Try this one yourselves, because it's very wordy, and I think you could figure that out. There's no calculating. I'll be right back. I'll just drink some water here. got it? Did you pick one? I'm not sure. A game involves drawing one card from a set of cards from 1 to 20. The desired outcomes in the game are to draw an even number or a multiple of 5. I'm going to tell you off the top, if you see the or, right, deck of cards, dice, anything, and they have the or, be ready, there might be an overlap. So non-mutually exclusive means this, right? Sorry. My bad. I got caught myself in this trap. Non-mutually exclusive is actually when they're joined. You can actually write that down, joined. Mutually exclusive is when they have nothing in common, like both of those outcomes have nothing in common. You can't have both. Independent and dependent, not even applicable here. Okay? Because we're not doing one after the other. Okay? We're not talking about two events. Not two events in series. Okay? We're just saying this or that. Then you're in the joint or disjoint category. So how many even numbers do you have? 2, 4. I would say best thing is to do this. Those are your evens. That's the set of even numbers, right? And then you've got your multiples of 5, which would be you start with 5 and then you go up by 5. And you can tell that there's an overlap, right? The 10 and the 10, the 20 and the 20. So in this case, these are non-mutually exclusive, okay? Because they have things in common. You should have on your study sheet non-mutually exclusive, have one of these and have joint. Just so that the wording doesn't throw you off and you have a quick way to reference it. Next, a student is given 2 spinners, one divided in 3 equal sections, the other one into 4 equal sections, as shown below. If both spinners are spun, what's the probability that the sum of the spinner is 3? I would equate this to a 3-sided die and a 4-sided die question. So let me do this. We call this an outcome table. I would say translate this to something you can clearly see. So you've got 1, 2, 3 at the top, and 1, 2, 3, 4 along the side. And then write out your sums. 1 and 1 is 2. 1 and 2 is 3. 1 and 3 is 4. Right? 2 and 1 is 3. 4, 5. Here you've got, right, 3 and 1 is 4, 3 and 2 is 5, 6, 5, 6, 7. So now you have all the sums easily accessible. Okay, they're very easy to see there. So you've got the 3's right there. So how many 3's are there? How many sums of 3? There's 2. And how many are there in total? 12, right? 3 times 4 is 12 total. But I don't see the answer. 1 over 6. So you gotta be able to. I showed you how to simplify, right? With the calculator, simplify your fraction. If you absolutely don't know how to do it, right? We divide both by, so it's 1 over 6. Okay, 1 over 6 is your answer in this case. So always be ready to do a little bit of work on the side so you can answer properly. All right, 13. The probability of rain is 60%. What are the odds against rain? Translate this to 60 out of 100, please. Just turn that into a fraction. Odds, you have to have the two dots. And if it says against, where will rain be on this, on the fence? Rain will be here, and that means that this will be not rain. Okay, so if it's against, then you have not rain first, then rain second. So let's replace those words with numbers. Where would the 60 go? If it's probability of rain, then it means that 60 times out of 100 it's raining, correct? So the rain will go here. And what goes on this side? 40, right? Not 100, please. So I'm going to show you 100 minus 60. It's 40. And you can just leave it like that. Okay. 20 goes into both of them, right? So you could have gone 2 to 3 if you absolutely have to. But I would say don't reduce unless you have to. Because if you make a mistake, it's going to bite you. So there we go. Yeah. It doesn't have to be in decimal. This you mean? No. Like you mean, are you allowed decimals? You would be allowed decimals. Yeah. So if you turned this into 0.6, right? And then you said 0.6, 0.4, technically that is correct. We don't like it, we hate it. But you would be okay. Next. Pizza place offers crust, sauces, cheese, toppings, and more toppings. Charles would like create a pizza by choosing one item from each category. Determine how many different pizzas can be made. This is just a classic 3 times 2 times 5 times 6 times 8. You just multiply all those categories, and that would be 1,440 pizzas. It's a one marker. It's a one marker. What if this had read? Determine how many pizzas can be made with or without veggies. This is with veggies, and you would have had to do another one where you omit the 8. You do the same thing, but you don't include the veggies, and then you would add it up. But I can guarantee you that question would have been a 2-mark question. Okay, so just be mindful of that. I like these ones because they make you think, but they've also kind of stay away from this one. Not always, but they stay away because there's a lot of newcomers to Canada, and a lot of teachers were saying this presents a barrier, right? Like to express yourself the way you have to here may seem complicated to some. So create a scenario. It's not like it's not going to happen. I'm just saying they're not very popular, where the calculation 8C5 and 9C2 would be appropriate. First of all, note, comps order does not matter. Okay, so you're not going to have specific positions. Okay, my favorite is teams. Just make teams or committees or groups. Okay, where you have no specific position. So you can say this: there are 8 seniors and 9 juniors in the gym. I don't know, just make things up. Okay, you've got 8 dogs and 9 cats. Do whatever you want to do, okay? And what are we gonna, we're making a group, created how many ways, how many teams, I should say, of How many members are in this team that you're about to create? 5 and 2, 7. Okay, 7 people. How many teams of 7 can be made with exactly 5 seniors and 2 juniors? So the 8 and the 9, you could have even made it more complicated where you say there's 17 people, 8 of them are seniors, 9 of them are juniors, if you wanted to. But I'm just going straight to the point. It's only 1 mark, so don't overdo it either. Okay? So the 5 and the 2 comes from there, and we know that there's 7. Okay? Make teams, make committees, make groupings. Okay? Go ahead. 12. This one stomped a lot of students back then. I remember this one. So let's get this out of the way. It's actually not too bad if you... I want to use this as a template for other things. A contractor has 5 workers he can assign to a task. This is on page 15, question 12. How many ways can the contractor assign at least 1 worker to the task? 2 marks. Okay? I will say this. The way I want to explain it is, this is the one you want to use. How many subsets can be made? And the formula is, I gave you this at one point where you use that one. So you go 2 to the 5 workers minus 1. 2 to the power of 5 is 32 minus 1 would be 31 ways. And I'll explain this a little bit more. This is where all workers say no. Okay? You're eliminating the one chance where all 5 of them are saying no, 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 we're not. Okay? So that would be, obviously nobody is assigned to the task. So if you remove that one from all possible, then there's 31 ways. Okay? Let me try that one more time. So for every, how many workers do we have? 5 workers, right? For every single worker, every worker can say yes or no. Yes or no, true or false. So that's why there's 2 choices for each worker that can be made. And that's 2 to the 5. Minus all saying no, no, no. That'd be 1 times 1 times 1 times 1 times 1. That'd be just the 1 time. So no worker being assigned. So that's 31 ways. Okay. It reminded me of the one question that was very similar to this. It had to do with salads. Someone at a salad bar. So salad bar, just write this down. Salad bar has 8 choices that you can pick from. How many salads can be made if at least 1 choice is made. So you can't say no to all of them, because then you don't have a salad, right? Hey, look at my salad. That's what my kids would love to do, right? Here's all the choices, right? No, no, no. Look at this, my salad doesn't exist. Right? Not possible. You got to pick at least one. Same idea here. And the reason, it's always to the base of 2, because you can say yes or no to every choice, and you've got 8 choices to make. And then you're always going to remove the one where you're saying no to every single choice. So it's like indirect reasoning. So that'd be 256 minus 1, so 255 salads. I was talking to Ms. Yosik about this one, and she hasn't seen this one in a long time, so we're kind of not too worried about it, but that's what this is saying. I'm not going to make you write this down, but another could be this. There are 8 true and false questions, right? 8 true and false. How many ways can you answer where you get at least one of them right? Think about it, true and false. Same idea, right? Out of the 8 true and false questions, you're going to go 2 to the power 8. You're going to subtract the one where you get them all wrong. And then you're left with, there's 255 ways to get at least one of them right. So same idea. If this is annoying you, bothering you, just leave it for now. I would say I'm going to take my chances on that one and just move on for now. I don't know if it shows up in one of those exams I asked you to try. 2:15. Okay. Let me just take I'm just going to see where we are time-wise. We have to go through it. There's nothing we can do to prevent it. Okay, so total of 3 marks. On January 21st, the probability of the overnight temperature low being below negative 27 is 11%. If the temperature is below this, the probability of Kara's car starting is 55%. If it is not below negative 27, the probability of the car starting is 91%. Create a graphic organizer, that's hint for tree diagram, to represent all possibilities for this situation. So please just assign some sort of wording to it that it makes sense, that you're not losing track of what's happening here. I'm going to say this. This is going to be my temperature being below. This is going to be temperature not being below 27. How's that? Because I don't want too many numbers there. So what's my probability of it being below? It's 11%, right? So I'm going to make this the 0.11, so 11%, which makes this what? 8, 9, right? Below, not below. So that's what comes first, and then it's whether or not the car is going to start. So I'm going to go start, not start. Start, not start. So here you have to be careful. If the temperature is below negative 27, the chances of starting is 0.55. Okay, so for me, this is below. So starting is 0.55 right here, which means that this is what? 0.45. All right. If it is not below 27, chances of it starting is 0.91 and 0.09. Please use your calculator for this one. Honestly, this is where you use a sword to peel an orange. Like you just go really, right? -1. There you go, 0.09. You don't want to get that wrong because it's so frustrating when I mark it and you're like, yeah, you totally know what you're supposed to do, but you made a mistake. Okay, so we multiply these all. 0.11 times 0.55. That gives us this. And then we get, this is 0.0495. I already did that. This gives us 0.8099. And this gives us 0.0801. And if you add it all up, you should get 1, okay? This should add up to 1. I should have checked. I actually didn't check because I don't make mistakes. It's nice when you get to that point. See what happened here? I added it all up. See what I get? 1.0009. Don't worry about it, because that's I did not round when I got these here. Or did somebody find a mistake? It was, you got 1 exactly? Okay, I'm just gonna go with it. But these numbers are good? Okay, I just mistyped. Okay. I'm gonna trust you on that. What's the probability that the car will not start on January 21st? So you have to go probability of not starting, you have to add all the non-starters. Where's the non-starter? Right here. And also right down here. So these two need to be added for not starting. And I get 0.1296, or you can choose if you want to write it as a percentage or decimal. It doesn't matter. You have that. Does anybody remember the backwards? I'm not going to do it right now because chances that they happen are low. I'm going to do that more towards the end, maybe just before, the day before. I'm going to remind you of how to do those. Next, page, question 14. So I hope these ones you're good. Usually it's pretty much hint, do your tree diagram, right? Next, 3 marks for this page. A teacher surveys her class of 29 students, finds out that 15 worked on an assignment, and 12 studied for a test. 7 did both. To me, this sounds like a Venn diagram. How many students did not work on an assignment nor study for a test? This 7 did both. It gave it away for me. Okay, so this is assignment. We've got 15. Test, we have 12 students that studied for a test. Our universal, we are told, is 29. Do you remember how to do this? 15 minus 7 gives you 8. 12 minus 7 gives you 5. And make sure you do not forget about your outliers. Always check. The only time you don't have to worry about outliers is if it says everybody has done at least one of them, right? If it says at least one, every student has been doing at least this or that, then you don't have outliers. So we go 29 minus, I'm going to just go minus 15, right? 15 is all of this, minus 5. I end up with 9. Okay, so 9 goes there. So 9 students, that's all you need to do here. If you state 9 students, that is enough work. So 9 students did neither. They were the outliers, okay? How do you write that again? In set notation, we go A, union T, not, right? If they ever ask for it. The teacher decides to randomly put students in groups of 3 for a class project. Groups of 3, hint, hint, groups. What is the probability? That's another big word there. Probability, groups of 3, that all 3 members will not have worked on an assignment nor studied for a test. It's 2 marks, so you gotta watch out for this one. You're making groups of 3, right? So I will say this, my NU is what? Out of the 29, we're choosing 3. Do you remember how to type that into your calculator, please don't forget that. You got to go 29 alpha window, and then just go to combinations. So 29 C3, that's 36, 54 groups. If you get the NU, you get 1 mark. Okay, so it's important to get your NU. But now what? We want the probability that all 3 are from the non-studying group, right? So what would NA be? Out of the 9, just the 9, I'm going to choose 3. Sorry, I like to think of it this way. And from the remaining 20, I'm going to choose none of them, right? So there's 20 that studied and 9 that didn't. So that's essentially 20 choose 0, that's always 1, correct? That's always 1. Anything choose 0 is 1. So it's 9 choose 3, that's 84 groups can be made with the 9 that didn't study. So now you're ready for probability. 36, 54, 84. And I want to say something about this one once you're done writing this down. This could have been very, if it says what's the probability that a student didn't study for any of them, then it would have been as simple as 9 over 29, right? That's just a probability. But because of this, making groups, it's taking it to another level. And the fact that it's a 2-mark question is taking it to another level. Okay, so if it just asks what's the probability of getting a student that didn't do either one of them, it'd just be 9 over 29, end of discussion, move on. Okay? All right. Keep going. There are 50 high school students in a small town. The school's cross-country coach wants to randomly select 9 students to form a team. How many different teams can be created? Perms or coms? Coms. Why is it coms? Because there's no particular order, there's no arranging for a picture, there's no positions. So it's 50, choose 9. That's it. And I already crunched that for you. That's a lot of teams, by the way. Yes, it's a very, very large number. If it doesn't work out on your calculator, they'll usually tell you just write the expression. Like if it's too big of a number, just write the expression. It doesn't happen very often, but be ready for it. Okay. The coach rents a van and drives his team to the race. Calculate the number of ways the students can be seated if there's a 9-passenger seat. What about now? Order matters. If you're seating yourself, if you're lined up in a line or seating or anything like that, order matters. So we can just go 9 factorial, or from the 9, pick 9. Because now we're just talking about the 9 that have been selected. They're now in the van, and so it's 9 factorial. Okay? Oh. This is assuming that, like, what if the coach has to drive? The coach has to drive, has to stay seated. That'd be 1 times 8 factorial, right? And it does say the students. I think this one is tricky. I'm going to go with the fact that so this is I'm just going to say if coach can sit anywhere. Yes. Yes. Coach rents a van. Can be seated if there are 9 passenger seats. Okay, because of the passenger. Because of the passenger, this stays. We're going to keep it that way. This is the answer. Yeah. 9 passengers, which means... I don't think this is a fair question. Okay. Okay, hold on. We're just going to pause here for a bit. State your assumption, okay? All right, let's keep going. Hopefully we can be done in half an hour. Finance. If the value of a house appreciates 4.10 per year, and when you purchase is 180,000, okay? In June of 2010, what is the approximate value in 2015? This is appreciation, right? So value will be initial times 1 plus rate over 100 to the power of years. In this case, we go plus because it's appreciation, yes. So we're going to go with 180,000, 1 plus 0.041 to the power of how many years? 5 years went by, right? From 2010 to 15. It's 180,000, 1.041 to the 5. If you do that, I'm going to go a little faster on these ones because I think you're all pretty comfortable with these questions. That's what you get. So in this case, we picked that one because it does say approximately, right? So we're just going to go with the one that's nearest to that question. We're good? $20. Okay, Dina is saving for a home renovation. She deposits $50 every month at a high interest savings rate at 460% compounded monthly. What will be the value of Dima's account after 4 years? If it says compounded, folks, it is TVM solver. Okay, like TVM solver is the one for you there. If it's simple interest, then it's a different story. Did I press record? Yes, okay. And so compounding, I'm going to start with that. And we're also putting $50 every month, so that's that. Final value is what we're going to figure out, the future value, I should say. And the payment is -50 because you're giving it to the bank. And at present time, you have no large amount being deposited, so that's a 0. This is 4.60. And it says 4 years, so we're just going to go 4 times whatever PY is, so that's 48. And so you solve for the future value. Let's do that real quick here. So there it is. It's 2629.47. So you can just leave it like that. As long as it has a dollar sign, you can just go and circle it, okay? And that's your answer. 2 marks. How much interest will she have earned after 4 years? Because this is the total interest, you can use this from the very first to the very last, which is the 48th payment, right? And if you do that, make sure you quit, and then you go finance, sum of interest, 1 to 48, and that's 229.47 interest earned. Or I need you to make sure you have this on your study sheets, okay? This is the other formula for investments. It'll be future value minus present value minus N multiplied by PMT. So this is very specific to investing. We go future value, which is 2629.47, minus the present value in our TVM solver is 0. So you just put 0 there. And then we have 48 payments of $50. So that's 2629.47 minus 48 times 50 ends up being $2,400. You get the exact same answer. I would use sum of interest if possible. I'm surprised they make this a 2-mark question, to be honest, but that's what it is. We good? Okay, next. Question 18. Lisette is 50 years old and wants to retire at 55, so near retirement. Her assets include $60,000 in GICs, $78,000 in checking, $192,000 in stocks. Right there, I'm seeing a problem, right? Too much in high risk. Too much in high risk investments, being too close to retirement. Make two recommendations to help Lisette strengthen her investment portfolio. Justify your recommendation, so you actually have to say why. I would say this, move most, if not all, of the money from stocks to GICs. And this is why we're going to justify that. She is close to retirement. And should lower her risk. You could even continue saying, if you lose it at that, being that close to retirement, you don't have time to make up for it, okay? Absolutely, you go for it, but I think this would be good enough in this case. So that's my first one. My second one is, I would say, move most of the checking account to a GIC or similar savings and I didn't necessarily talk about this one, but a checking account doesn't earn you a whole lot of interest, right? A checking account is just a checking account. So she's got what, $78,000 in something that isn't earning a lot of interest. So I would say move most of the checking account to a GIC or similar savings account to earn more interest. You're saying why, you're saying what should be done and why it should be done. Okay, you're justifying it. So you've got the 2 marks in this case. Or to have a higher return on the investment and whatnot. Okay, let's keep going. Serge invests $12,000 on his 30th birthday. If his investment earns 6% interest, compounded annually, there's the word compounding, can't use simple interest. Apply the rule of 72 to estimate how much money he will have when he retires on his 66th birthday. First foremost, let's figure out the doubling time. 72 divided by 6. You get 12 years. So you're actually finding the amount of time to double. So this is where it's different. How old is Serge at the? So you can do it two ways. Maybe I'll just do it the way I've shown you. At time 0, you've got 12,000. 12 years go by, you're at 24,000. Oh, wait, no. This is going to be a bit more complicated this way. Not wrong, but I think it's better to stick with the way I solved it. Sorry about that, guys. Guess what? It's probably good some modeling of what to do when you make a mistake. I'm going to say when he's 30, right, that's going to be the age and how much money. So when he's 30, he's got $12,000. 12 years go by, right? So 12 years go by, my money doubles. It's 24,000. Another 12 years go by. That's when he turns 66. You're going to double what he had previously again. Okay. So there you have it. Because of the 30th birthday, because they're saying how old he is, I start with 30 under these circumstances. Yes? Oh. 54, as I was saying. One more. We need one more. 12. Yeah, there we go. Thank you. That's the danger of staying too late. So that's 96,000. 96,000, yes. Should just look at my answer key and then I'll get it. Okay, so he will have $96,000 using the rule of 72. It might be more, probably be more if you use the TVM solver, but that's not what they want you to do. They want you to use the rule of 72. Okay, so the 72 helped us to figure out the doubling time. And so remember, the time goes up consistently by the same amount. It's the amount of population, money, or whatnot that you double. Okay. Question 20. So Harsimran invested 20,000 in simple interest. Notice that. After 12 years, the future value of the bond was 26,000. Okay. Determine the annual interest rate. You can do it in several ways here, but I'm going to start with this one. The interest in this case is 26,768 minus 20,000. That's how much interest has been earned in these 12 years. Okay, I subtract the two amounts I have. This would be considered A, and this is considered P, just so you know. Okay, so interest is right here. 6768 is equal to, principal is the amount you initially invested, times R, times 12. And so what we're going to do here is we're going to simply go 20,000 times 12. It's 240,000 R. Okay? And then divide both sides by 240,000. So you go, and when you do that, you get this. 0.0282 is equal to R. So you can leave it there, or you can say that R, if you multiply that by 100, is 2.82%. Okay. Could you have used this formula? You think? Absolutely. If that's the one you would have rather have used, that would have been just fine. I think I'm not going to show you how to do that, but you would get the same if you just isolate for R on that one. Determine the rate of return. Rate of return in this case would be interest earned interest or earnings divided by principal. Okay, what you've put in times 100. So in this case, we already know our interest, but maybe I'll just show you one more time here. Divided by the 20,000 you put in the first place. It gives you 6768 divided by 20,000 times 100. And you get 33.84% is your rate of return. Not the interest rate, but rate of return. Keep going. Five marks. Okay. Maurice needs a truck for his new job and it will last 4 years. He has the following two options. Option 1, purchase the truck. Taxes included. Okay, please don't add taxes if it does say that. Okay. With no down payment at an interest rate of 4% compounded monthly for 4 years. It's important there, the 4 years. Or option 2, you can lease the same truck. There's a down payment, monthly payments of $850, taxes included. He would be allowed 20,000 kilometers. 20,000 kilometers per year, and then pay 18 cents per kilometer, taxes included as well, if you go above the limit. What would be Maurice's total cost in option 1 if he makes monthly payments? You notice that there is no monthly payment, and that this is a 2-mark question, so figure out the payments. So we know the compounding is monthly. We know that we're supposed to figure out the monthly payment, so this is 12. If it's a loan, you want future value to be 0. Payment is to be determined. For the present value, there is no down payment, so we just go with that. The interest rate is 4, and we're doing this over 4 years. So 4 times 12, it's 48 again. So let's figure out our payment there. I get a payment of $1,020.45. But that's not the answer, is it? It's part of my answer. It says the total cost, right, of truck. Okay, so cost is N times payment plus down if there is one. If you want the cost of the computer, the cost of the truck, anything, you take how much did you pay for the loan and then add the down payment if you did have a down payment. So 48 times 1,020.45. That's all. And that gives you $48,981.60. Includes interest. That's why you end up paying back more than what you borrowed, right? Because they've added interest over years, over the months, I should say. If Maurice drives 25 kilometers annually, what would be his total cost in option 2? Show your work. Let's deal with the mileage. The limit, we're told we're allowed to drive 20,000 kilometers per year. Okay? So the limit is 80,000 kilometers. No more. After that, we need to pay. We are over because we drove what? We're driving 25 kilometers. Okay? So we're going to go 25,000 times 4, because we drove that for 4 years. And we're going to subtract the limit from it. That's 100,000 minus the 80,000. So you're 20,000 kilometers over. Is this important? Not my final answer just yet. So mileage is definitely a problem here. Cost would be 20,000 times the 18 cents per kilometer. Taxes included. That's $3,600 that you're going to pay just for mileage. And now we can enter the final phase of this, whereas lease is down plus payments plus mileage. And the only one that isn't taxed is your down payment, guys, and a lease. Okay, your down payment is never taxed. So don't be adding taxes, even if it says, if it doesn't mention including taxes, don't add taxes. So what is it? Our down was 5,000 plus the total payments. Our payments were 850. We made those for 12 months in a year and 4 years. So basically 48 payments of 850. Plus the mileage. Everything has taxes, so I don't worry about the taxes. So that's 5,000. Can you see that? Yeah. 5,000 plus 40,800 plus 3,600. This is a lot of work for 2 marks, in my opinion. So the total cost of option 2 is 49,400. Please make note of the fact that the only thing that isn't taxed is the down payment. So they don't have to tell you including taxes or so. It just never gets taxed. The payment, if it isn't taxed, you need to add 12% to this 850. The mileage, if it didn't tell you that the 18 cents were already taxed, you would have to add taxes to that. Okay? So make sure you add taxes to these components if they aren't there. Which option would you suggest? You can say buy, okay? You keep the car. You keep the car at the end. Or you can say lease. Payments are lower. I don't know if you noticed that, but the payments for the lease is only $850 a month versus the other one is 1,000 and something. Okay, so I would say buy as well. Another option for buying would be no mileage charge, no mileage costs, right? Or limits or restrictions. So that is another thing you can put down for a pro for buying. Another pro for leasing would be you can return it when you're done with it and get another one. Okay. All right, done with finance. Let's go to design and measurement. Not many left. We'll do it quick. How many cubic yards are in 54 cubic feet? I hope that you have this one on your study sheet. 1 cubic yard has 27 cubic feet. Make sure you add this to your study sheet. That's a very popular conversion rate. So 54 cubic feet. If you wanted to convert that to cubic yards, you just go 1 cubic yard has 27 cubic feet. Sorry, cancel out the units, right? They always cancel out this way. So it's basically 54 divided by 27, which is 2. So the answer is 2. Make sure you add that one right there on your study sheet. Next, 1 can of paint covers an area of 200 square feet. How many cans can be purchased, need to be purchased to cover a 60-foot by 8-foot wall? So area of wall is 60 times 8, which is 480 square feet. Cans, we just go 480 divided by 200, and that gives you 2.4. What do you need to answer there? 3. You always have to round up on these ones. You cannot say 2 or 3, you have to round up. Because as soon as you need a little bit more than 2, you need to buy that third can. There's no way around it. Okay. Let's keep going. This one is a longer design and measurement, where you have a little bit of choice, but you're going to pick the same as me, okay? James's landscaping is 50 by 40 yards. So this is 50 feet by 40 feet, okay? He will construct a concrete walkway with a uniform width X, okay? So it's X all around a width of X, as illustrated. The walkway must be at least 3.5 feet wide, at least, so it could be more. The concrete must be 6 inches deep. The concrete costs $3 per cubic foot, plus GST and PST. Sod is 40 cents per square foot, plus PST and GST. Just wait, okay? The budget for the project is $21.50. So that means that you can't surpass that amount. So they give you some leeway there. Okay, what's the width of the walkway? It says at least 3.5. Let's make it 4 feet. Okay, at least 3.5, we're good. Dimensions of the sod then. Where's the sod? The sod area is the shaded part right here. So basically, if you're saying this is 4, it's 4 all around like this. That's the width of the walkway around. So what would be the dimension here for the sod? It would be 40 minus 4 minus 4, that is 32. Then you go this way, it's 50 from end to end, take away 4, that's 40, sorry, what am I doing? 42 here, 42, not there. So it's 42 by 32 is the sod area, so you do the work there, but then you come back down here and say it's 42 by 32 is the area that will be covered with sod. 1 mark for that, guys. You pick the width, and then you just have to do a little bit of work to come up with the sod part. And keeping this in mind, it says calculate the total cost of the design, and there's an error there. Well, it's not an error, but back in the days, PST was 8%. Please cross that out and say it's 7%. So we need to pay for what? For concrete. Concrete only goes on the walkway, right? And what are you thinking, surface area or volume? Volume, right? When you fill something up, it's volume. So watch what I'm going to do here. Volume is large minus small. I hope this rings a bell. What am I talking about? I'm going to take the large, the whole yard, find the volume of that, and then take away the volume of the center, and that'll leave me with the walkway. That's my plan here. So large would be length times width times height minus length times width times height. That's the volume of a rectangle, right? Rectangular prism. For the large, it's 50 times 40 times, what's the problem with the height or the depth? If you look, it's 6 inches. What do you do with inches to make it feet? You just write it over 12 like that. It's half a foot. Okay. Minus the sod area is 42 times 32 times, it's still 6 inches deep, right? So we'll just go like that. You know what? Some of you might say, what are you doing? 6 inches, right? 1 foot has 12 inches. If you cancel that out, it's 6 divided by 12. It's half. So if you want to do it on the side, there's nothing wrong with it. If you crunch this, just write this down for today. This is 1,000 even. Minus, if you crunch this other part, that's 672 even. And guess what? This is a nightmare to mark, because if a student picked a different number, you have to recalculate everything. So this is the volume that needs to be filled with concrete, all right? So let's do the cost. How much does it cost for concrete? 3 per cubic foot. This is already cubic feet, right? No converting necessary, and it's a whole number. Remember, you'd have to round it if it isn't. So it's 328 times $3. That gives you, and taxes. Let's do taxes right away. That gives you 110208. Almost done, not quite. We need to do the sod part yet. I'm going to do that on the side here. Sod. What do we need for sod? It's the price is in square foot. So we're going to go area. It's just length times width, which is 42 times 32. So that's 1,344 square feet. Cost. It is a whole number. If you had done the math and this would have been a decimal, round it up to the nearest square footage when you're trying to find the cost, because you can't buy partial square footage. So it's 1344 times 0.4 times 1.12. We're slapping taxes right away so we don't forget. That gives you $602.11. Also important. And now is the total. Total is just 1102.08 plus 602.11. And that's 1704.19. Are we under our budget? We are. We have money left over. We can go to a nice warm Mexican vacation or something like that with the rest. Not really. No, that doesn't even get you there. Not even to the airport with the gas prices. We're almost done, guys. Logical reasoning. Half. Once. So let's say you made a mistake. You forgot your units elsewhere. You forgot centimeters, like when we did the functions. I don't take off again. Like, it only happens once. Yeah, okay. And don't forget your two decimals when it's dollars. Like if it's 0.8, then it has to be 80. Okay. All right, keep going. Your favorite. Truth tables. I hope you have something on your study sheet with conditional statements. So there's a truth table, PQ. What does this mean? If P then Q, right? That's what that is saying. When is it false? What's the only time this thing is false? If you have, sorry, if you go from true to false, then the entire thing is false. Okay, that's one thing I want you to remember about conditional. So true, 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 false. What is this supposed to be? False, right? Anything else is true, guys. Anything else is true. So we want M to be false and N to be true. So let's go look. It's a multiple choice. M false, N true, right there. Okay. I don't want to go into the remember all the rules right now because I know you want to go home. So I'll remind me if I forget. But here we go. This is the next one. Consider the conditional statement. If x has a positive value, then x squared is greater than or equal to than x. This is next. Provide a counterexample, guys. They're saying there is one. Okay? They're saying that if it says provide a counterexample, find an instance where this is false. How about this? If x is equal to 0.5, then, okay, let's try that. If x is equal to 0.5, what's x squared? It would be 0.5 squared. What's 0.5 squared? It's 0.25. Is 0.25 greater than or equal to 0.5? Because we just found x squared, right? And we said that x is equal to 0.5. So we're finding a counterexample where x is 0.5, and if we square x, we get 0.25. So this is false. Okay, 0.25 is not greater than 0.5. So a decimal squared gets even smaller and smaller and smaller. It goes back to the exponential functions. If the value you have for b is between 0 and 1, and you keep compounding it, it actually decreases, right? Your function decreases. Let's keep going. Last one. Yay. A universal set is defined, so S, that's our universal. Two subsets are given. O is odd numbers from S. P is prime numbers based on S. Draw a Venn diagram. I would first do this. O, based on this, would be 11, the odd numbers, 13, 15, 17, 19. Okay. And then the P is my prime numbers. Which is 11 a prime? It actually is. 13 is a prime. 17 is a prime. And 19 is a prime. Only one and itself can divide it. That's how you know it's a prime number. If you need a refresher on primes, right? 2, 3, 5, yeah, 13, 17, 19, and so forth. So if you want a few examples, have a few. I don't think you need a whole lot, but that's good enough. So right away you see that there's an overlap. 11, 11, 13, 13, 17, 17, 19, 19. What do you notice about P and O? Every single value in P is also in O. Do you see that? There's P subset, okay? P is a subset of O. Just a reminder. So subset, you do like an egg, or a nest egg like this. Where P is 11, 13, you actually have to write them in like this when they give you the individual items of that set. And 15 is the only one that is, it's in O, but it's not in P. I'll highlight that one. 15 is there. And don't forget your universal. And there's something we're forgetting right now. I think a 1 mark is not fair for this one. There are, remember this is your universal, there are, in this set, there are values that are in neither one of these, so we got to have them on the outlier, which would be your even numbers. So the 12, the 14, the 16, the 18, the 20 are your outliers. Yeah, did I forget one? Which one? One, two, three, four, five, six. Sorry, say that again. Oh, okay. Yeah. Yeah. Thank you. And universal would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. Thank you. And do I have 10 though? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 elements in total. That's what you want to check for. And so this is one of those where they give you each individual element. You're supposed to put it where it belongs. Determine O union P. Okay, union elements in O or P. Okay. So you're actually supposed to write them out like this. One more question, ladies, then we're good. O union P. So O union P, that would be all of them combined. Okay, all of them combined. So we just go 11, 13. It's essentially O. 15, 17, 19. Yes. It's essentially all of O because the union of the two, all you would have to do is make sure 15 is part of it. Like you basically listing all the elements in both of them, but no repeats. Okay. So there we have it. Determine the number. Watch this. Okay, the number of elements that are at the intersection of O and not P. Where would that be? Intersection of O. This is O. And not P. That would be just the 1. Just the 15. What's the number of? Okay. So O is all of it. Not P is everything else. So the only thing that not P and O have in common is the 15. Okay. So there we go. One element. That concludes this exam, guys.